Orano Federal Services business combines the capabilities, technologies, and resources from multiple Orano companies to serve the United States Department of Energy and its subcontractors in all phases of the nuclear life cycle.
When we first met our team sponsors, I was a little nervous at first. We had two of them, Brad and Sven, and they were both super nice guys. Meeting a PhD in nuclear engineering is a little intimidating.
When we met the sponsors, it was the Senior Design One breakfast, and I don't think anyone really knew what to expect. But when Sven and Brad came in, it was like we'd been working on a team with them forever.
The nuclear industry is very costly and time-consuming. Optimization studies like the project assigned to the Orano team are essential for making sure time and resources are not wasted.
As of the end of this year, the Shearon-Harris nuclear power plant is expected to be the only nuclear power plant in the United States to not have any form of on-site dry storage. The setup cost for a dry storage system at the Shearon-Harris plant would be extremely expensive. So the plant is looking at ways of offloading their nuclear fuel, spent fuel pools, they have 4 of them, to other locations so that they can prolong the amount of time before they will need to purchase dry storage facilities.
Our project is the optimization study for offloading the Shearon-Harris spent nuclear fuel pool using transportable, aging, and disposal canisters.
We had to consider both time and cost of multiple different alternatives, including using 1 train or 2 trains for the offloading process, as well as using 1 transfer cask or 2 transfer casks. Also, due to the nature of the nuclear industry, we had to provide 3D models that our sponsors could use during presentations to help improve their presentation quality and hopefully establish funding for these nuclear projects.
Hi, I'm Drew Began. I'll be presenting the optimization study for BWR fuel in ARENA. The 2 things I want to show you here are the discharge date and qualification date. The discharge date is when the fuel is actually removed from the reactor, and the qualification date is when it can be removed from the pool after it's been cooling. We created the model assuming that it would start right after our graduation, so beginning May 11th, 2020. They work roughly 10-hour days at the plant, and that's what we used for this part of the process. All the fuel assemblies start here, where with fuel rods there's 4,400 BWR fuel assemblies. Before they can actually begin the offloading process, there's a lot of preparation that goes into it. We put aside 30 days here for them to get prepared to start offloading. The next step is the decision of an outage. Every nuclear plant has an outage every 18 months, and Shearon-Harris's next outage is April 4th, 2021. So when the fuel gets here, if it has reached that date, it'll then go into an outage delay of 28 days, which is roughly how long it usually takes per outage. If the fuel has not reached that date, then it will continue in the process as normal. The next step is batching rods to DSCs. A DSC is a dry shielded canister, and every DSC for BWR fuel can hold 44 fuel assemblies, as you can see in the batch size here. After the rods have been batched to DSCs, the next step is to see if a transfer cask is available. If there's a transfer cask available, they will continue on and move the fuel to a transfer cask where it can then be brought to a horizontal storage module. The horizontal storage module is used for BWR fuel to bring the fuel from a transfer cask to a transportation cask, as seen here. Once the fuel is brought to a transportation cask, it can then be brought to the train so it can be brought out for delivery. Behind each of these modules, there's a triangular distribution of data. This just depends on how long each process will take. Once all the fuel is brought to the trains, there's a decision to see if train 1 or train 2 will be brought out to the final destination. Whichever one is available next will take 5 DSCs to the rail, as seen in the batch size here. And once those 5 are loaded on the train, they can be brought to the final destination.
So what I have here are some of the 3D models that we created for the project. This first model is the NAC 21 tag canister printed with acrylonitrile butadiene styrene. via FDM or filament deposition modeling, or commonly just known as 3D printing. So again, yeah, here's the parts. We don't have all the parts with us due to the COVID-19 restrictions. Some of them are still on campus, so we'll be picking that up and getting it delivered to the supporter when we can. But these are some of the parts of the TAD canister. The top lid, the top cap, right here. This is part of the basket assembly. What we're missing are 30 heat transfer discs that'll slip onto this. So aside from the NAC 21, I have with me a TN44B TAD canister, small scale model. This is a 1/33rd scale. This is really just for design verification. It's really the same idea as the NAC 21, a little bit different. There's, again, instead of 21 fuel assemblies, this one accommodates 44. But the same main idea with the top cap, the plug, and the plug additive. Made with the same material, acrylonitrile, butadiene, styrene, ABS. Same method, FDM. And then the third part I have here with me is the high burnup lid. So this is an extra part that we printed for Orono. And this is actually 3D printed in stainless steel. So this was, again, an FDM method, a new printer that the school has, that Dr. Riquet has. But again, you can see the resolution for this printer is actually really great. So I have on the screen the 3D model, and we were able to capture all the features that we wanted to.
It provides them with something physical instead of just a picture on a screen or a presentation when they do present this.
My focus of this project was creating a tool to help determine how long offloading all of the spent fuel from the Shearon-Harris nuclear power plant would take, given all the preparation and logistics involved in the process as a whole. The tool was developed in Python and was designed to read a CSV file from Excel with information on the fuel that needed to be offloaded, and given all the constraints associated with it, output the length of time that the process would take. Additionally, by design, the code can be used for future fuel removal simply by adjusting the information that is inputted.
I have been working on the optimization function this semester and helping to calculate the costs that need to be considered for the possible strategies to help find the optimal solution.
After creating timing simulations for all the potential alternatives, such as the one Drew demonstrated earlier, and comparing those to the cost of each alternative that we established in our cost file document, we were able to create an objective minimization function that can be used to determine which of the alternatives is the best. Because of the ever-changing nature of the nuclear industry, we created the Python tool so that our sponsors can use it on future projects due to its non-proprietary abilities as opposed to Arena, which they'd have to buy a license for. The numbers you're seeing on the screen now, ranging from 0.00 to 1, are the weighted value of preferring money versus time, with a value of 0 meaning they absolutely prefer only time, and that's the only consideration, a value of 1 being only money, and a value of 0.5 being an equal split between their preferences. The majority of the data lands in the 2-train, 1-transfer cask alternative. On some of the graphs we'll be displaying now, you can see that it's not till far later in the process, when money is significantly weighted higher than time, that a 1-train, 1-transfer cask alternative becomes preferable. So taking all this information into consideration, we recommend, for the majority of cases, using 2 trains and 1 transfer cask for both pressurized water reactor fuel and boiling water reactor fuel for the removal of the Shearon-Harris nuclear power plant. We
Or the
Orono
TAD
Team.
And this
It's our senior design project.